Welcome to lesson 6. We're going to look at rational versus irrational numbers. Here are the two things we're going to look for. We're going to use our calculator to simplify and evaluate expressions, so making sure that we can use it, and that means showing that we use it properly and that we can show our work for that as well. And then being able to just tell the difference between rational and irrational. And so what do I mean by that? So here are the things that are all written in here. So if I can write it as a fraction, it's rational. Or if it's a decimal that terminates or repeats, it's rational. And I'm going to put this into the notes as well. If it cannot be written as a fraction, so it cannot be written as a fraction, or it's a non-terminating, non-repeating decimal, it's irrational. So that's what we're going to put in here into our notes. So again, starting off with rational, we have whole numbers. Oh, I like to write my notes in black. And why? Because whole numbers can be represented as fractions. So anything, so let's say I have 9, I can make it 9/1. So anything that can be turned into a fraction. Also, if it is for decimals, I'm going to put in the 2 parts that can be true. If it terminates, meaning it ends, or if it's a repeating decimal. So for example, if I keep on getting 0.3333, if that happens, it's rational. Or if I get one that's like 0.5, that's rational, it ends. Irrational numbers, so they can't be represented. Hope I spelled that wrong. Represented as fractions, or like pi. It's just a non-terminating, non-repeating. Like if you ever have people go and say, hey, let's talk about all the numbers of pi, and it goes on and on forever and it doesn't repeat. That's why it's irrational. Non-terminating, non-repeating decimal. And also, if you have a number that with a square root symbol, a radicand that just can't be simplified easily, like let's say like -10, I can't get that into a nice simple number, so this is also going to be irrational because I can't simplify it to a perfect square. All right, so this is what we have. So let's look and scan and try to identify any whole numbers. Just looking through, and we have tons of numbers with square root symbols, so let's simplify those first. I'm going to use blue for these. So I know 81 is a perfect square. I get 9. So that is definitely going to be rational, because 9 can be a fraction, 9/1. 101, nope. 100 is a square number, but not 101, so that's going to be over here, square root of 101, irrational. Square root of 121, yeah, that's 11. So that's rational. That would be 11/1. Ooh, 56. Think about your squares again. So if I'm counting 36, let's see, 4 times 4, 5, let's see, 6 times 6 is 36, 49. After 49 is 64, so no. 56 is between those two, so square root 56 doesn't work. 196 is rational, since we know that would be 14. See, I told you it would be really helpful if you can just recognize these numbers. 2 square root 9 would not be. Yeah, that was the same thing as if I would have had square root 18. So no. -10, yes. I can do that as -10/1. 1/2, yes, that's a fraction. 1/3, yes, that's a fraction. 1/7, yes, that's a fraction. Pi, no, because we know when we try it, it goes 3.14 on, so it's irrational. Which means the same thing for 2 pi. goes on forever. 3.5, yes, because I could represent that as 35 over 10. And how about 3.12, and that means it's going to keep repeating. So 3.12, 12, 12, 12, yes, that counts because it's a repeating decimal. All right, so there you go. I put these down here. Let's hit pause and jot these down into your notes. And hopefully this helps you recognize a rational number, because again, it's a number you can actually see as a fraction, or if it's a decimal, it ends or it repeats. Okay, we're going to try and determine if the product of 3 square root 2 and 8 square root 18 would be rational or irrational, and we're going to try and explain our answer for this one. Again, this was a Regents problem. So let's see if we can just simplify this out first. We have 3 square root 2 and times 8 square root 18. So I'm actually going to find the factors of 18. So I have 2 times 9, 9 is square, and 3 times 6, that doesn't work. So I'm going to use 2 times 9. So 3 square root 2 times 8 times 9 times 2. And let's see, square. So I have separating these two. And I'm going to write the first part out too. All right, so let's simplify. I'm going to simplify that 9 to a 3. So that's 8 times 3 times square root 2. 3 times square root 2. All right, so looking here, I'm going to rewrite it and put all my whole numbers here in the front. So 3 times 8 times 3 times square root 2 times square root 2. All right, 3 times 3, I know is 6. 6 times 8 would give me 48. And watch what I'm going to do here. I'm actually going to put both of these inside here. And what do you see? What do you notice would happen here? So if I were to actually combine them together, 2 times 2, I would get 4. And 4 is a square number. So that is something that's really interesting here. And I could actually simplify that out. I'm going to just use my eraser for a second and just put 2. And 48 times 2 is 96. That's my final answer. So is this rational or irrational? This answer would be rational. The product of 3 square root 2 and 8 square root 18 is 96, which is rational. I can express 96 as a fraction, 96 over 1. All right, and there we go. I've answered this question completely. So what was the hot spot with this one? It was recognizing this part over here. I'm going to highlight it in yellow. That I can take these two numbers, the square root 2 times the square root 2, and that would be the same thing as just square root 4. I can recombine them together and they would just make that square root 4. Okay, and that is something that I could actually find. I could actually square that and find the number up. So that's it for this one, Math Marbles. Let's put this one into your notes. You're going to do a lot more practice with these types of problems. Please make sure, again, if you are using your calculator, that you're showing all your work. And also use some of your notes to recognize if something is rational or irrational and use it to justify your answers. As always, in your checkpoint, if you find that you're struggling, ask for the type of feedback that you need and be very specific about what you need feedback on, as well as your level of support. Is it you want to try things out and see if you're on the right track, or do you need more targeted support because you're a little lost in a problem? That's it for today. I will see you in the next lesson. Be well.